Okay, so with angle proofs, we start off just like we did with segment proofs, and except this time there's a lot of definitions and stuff, as you can see on this paper. I'm not going to go through all of them. Most of these we've already learned, but I just like there are more definitions and more postulates and theorems and stuff involving angles than there are segments. So that's why there's so many on this page. Just like with the segment notes, these are not the only things that are used, although I did put quite a few things that are used in proofs, but it's not limited to just this, like other stuff could be used too, but these are the most common things we use. Again, reflexive, symmetric, and transitive property can be used with angles, just like with segments. And then I just put some like things that we've learned, like angle addition, just like how segment addition is used in a segment proof. Angle addition is like if you have a picture like this and the two little angles add together to equal the big one. If, say, you were given a picture and you're told that you had an angle bisector, you could conclude that these two pieces are equal if I told you that was an angle bisector. Complementary angles, if I tell you that angles are complementary, you could say that the measures add to 90. Definition of congruent angles, that's like the same thing as definition of congruent segments, if you remember. Remember how the symbol changes? The angle equivalent of taking the bar off or putting the bar back on is and with angles, we put this little m. This little m means measure. So this says angle 1 is congruent to angle 2. Remember, that refers to the figures themselves are the same size and shape, versus the measures are equal. This refers to like the actual degree measures. The numbers are equal. So flipping back and forth between these is definition of congruent angles. I put stars. Before class, I was like, let me put some stars and stuff I definitely want to talk about, but then I realized there was kind of a lot. So again, just like with last time, it's kind of easier to just like see it used in a proof. But these two, linear pair theorem and definition of supplementary angles, these are kind of used a lot and kids always mix them up. So a lot of times in a proof, you'll be told that you have a linear pair. And then we know that linear pairs are supplementary, right? So if you're given that a pair of angles are a linear pair and you want to say that they're supplementary, the reason for that is linear pair theorem. Once you determine that the angles are supplementary, think about what is the definition of supplementary angles? Well, those are angles whose measures add to 180. So you'll see, I'm going to do an example today where we use both of these, but these are used a lot. Substitution is used kind of the same way as segment proofs, like moving things around, replacing things, whatever. Same thing with addition, subtraction. Over here, complementary, I already said. Perpendicular, I don't think we've talked about perpendicular lines, have we? I don't know, maybe you guys already know what perpendicular lines are. We usually do something called geometric constructions when we're in school, which you need like a compass and a protractor. But since we couldn't do that, I realized I never defined perpendicular. If you don't already know, perpendicular lines are lines that form right angles. So like if I said these two lines were perpendicular, you could conclude that these are all right angles. So there's 4 right angles. This is the symbol for perpendicular. It's an upside down capital T. So it might be like this, like watch, I'll label these. I know this is really small, but if I said like line L is perpendicular to line M. Sorry if you can hear the loud garbage truck going by my house right now, it's garbage day. But if I said line L is perpendicular to line M, you would then conclude that these are right angles. So again, I think there's an example in these notes that I do one of those also. And then once you determine, so like these two kind of go together a lot too, because if I tell you that lines are perpendicular, then you concluded that there's a right angle. And then a lot of times you have to say that the measure of that angle is equal to 90. So that's just definition of right angle. If you ever have to say that vertical angles are congruent, that's called vertical angles theorem. Sometimes you might have multiple right angles that are congruent and you can say that they're congruent to each other. You can just say all right angles are congruent. You don't have to like do out anything fancy. And then lastly, these two, and again, I know I'm going through this fast, but as things come up, like it'll just make more sense. So these two are very similar. Congruent complements theorem, congruent supplements theorem. They don't come up a ton. They're kind of like shortcut theorems. And so basically how they read are, I'll just kind of do them both together, is if you have angles that are complementary to the same angle, or to congruent angles, the angles are congruent to each other. And then congruent supplements theorem is the same thing, but with supplementary angles. I could explain it 100 times, but the easiest way to see it is if we use it. So the first time that it's used, I will let you guys know and fully explain it. But I just want to let you know that they exist. So like if I had angle 1 is supplementary to angle 2, and angle 3 is supplementary to angle 2, then angle 1 and angle 3 are congruent. It's kind of like transitive property, but for complementary angles and supplementary angles, which seems like weird to think about. But again, when we see it, I'll let you know that it's going to be used. So this is a lot. I get it. I think that showing you examples is probably just going to be the best thing that will help. So I'm just going to start. So use this as a reference page, you know, if you're like trying to figure out a reason for something, like hopefully this is helpful. Okay, so the first proof that we're going to do is actually a proof of congruent complements theorem. So it shows like why congruent complements theorem is true. And so I think I said this last time that a lot of time in geometry, proofs are like proofs of other theorems, if that makes sense. So we are given here that 1 and 2 are complementary. So that means those add to 90. And 2 and 3 are complementary. So see how 1 and 3 are both complementary to 2? So really we could do this in one step using congruent complements theorem and say that they're congruent, but this is a proof of why that's true. So we're going to show out all the steps and why it's true. So obviously we start with restating the given information. Step 2 says the measure of angle 1 plus measure of angle 2 equals 90. Measure of angle 2 plus measure of angle 3 equals 90. Well, how do we know they add to 90? Because we know what complementary means. So we know the definition of complementary. Step 3 says 1 plus 2 equals 2 plus 3. So what was done here, see how these are both equal to 90? So they took 2 plus 3 and they plugged it in here for 90 because it's equal to 90. So then you can replace 90 with it. A lot of times kids think this is transitive because these two expressions are equal to the same thing. So now they're equal to each other. But there's too many angles and like too much going on for transitive. Transitive never has like expressions. It's always just like 3 angles. So this would just be substitution, property of equality. Does anyone see what was done from step 3 to step 4?
Subtraction.
Subtraction, nice. Was that Jake?
Yeah.
Yeah, nice job. So they subtracted angle 2 from both sides. So that's subtraction, property of equality. And then lastly, see how it goes from equal sign to congruent symbol, the m's in the front to no m's in the front. So we're saying the measures are equal and now we're saying the angles are congruent. That's definition of congruent angles. So there's our first one. So they're similar to segment proofs, just now it's talking about angle properties and angle definition. So it's like kind of the same idea. I think kids usually find angle ones easier. I think, I don't know, I don't remember. Just because I feel like sometimes the stuff that we do in an angle proof just like flows better, it makes more sense than segment one. Okay, so there's our first one. We're ready for the next one? I'm gonna post this filled in too. Go ahead, who's asking?
Yeah, can you just pause for a second? I'm trying
Yes.
to write it down.
Okay, yeah, thank you for letting me know. Okay, all set?
Yep, I'm good.
All right, cool, thanks. So example 2, here's example 2. We are given that EDG, so EDG, that's this one, is congruent to FDH. FDH, that's this one. So those two angles are congruent. Kind of hard to mark on here since there's so much overlapping. And then we're being asked to prove that 1 is congruent to 3. So first thing we do is restate the given. Step 2 says the measure of angle EDG is equal to the measure of angle FDH. So their measures are equal now because we were told that they were congruent. And the definition of congruent angles is that their measures are equal. So this is just definition of congruent angles. Recycling's here now. Kids can't hear them. Okay, let's look at the next one. The next one says measure of EDG is equal to the measure of angle 1 plus measure of angle 2. And then FDH is equal to 2 plus 3. So let's look at the picture. Let's zoom in a little bit more here. So it said EDG, the purple one, is equal to 1 plus 2. And then FDH, the blue one, is equal to 2 plus 3. So that would be angle addition. Small angle plus small angle equals big angle. So just like segment addition, we have angle addition postulate. Okay, so now we have 1 plus 2 equals 2 plus 3. So now we're saying that these two are equal. Does anyone see why those two could be equal? What did we do here?
You substituted?
We substituted. Anthony, was that you? Yeah, awesome. So we substituted. So what they did, in case you didn't see it, is they took 1 plus 2. See how 1 plus 2 is equal to EDG? And so they plugged that in there for EDG. And then we took 2 plus 3, which is equal to FDH, and plugged it in right here for FDH. So that would be substitution property of equality. Now the rest of it is kind of the same as the last one. And I will say a lot of angle proofs kind of have this flow at the end where you have like two expressions equal to each other. We have the repeated one on both sides, 2 and 2. We take 2 away. So we're going to subtract measure of angle 2 from both sides, right? So that's subtraction property. And that's how we got angle 1 equals angle 3. This is why it's important to write out the full name, because if you, a lot of times kids will try to just put sub prop, but sub and sub, these are both subs. So you kind of have to write out the whole thing. So substitution, subtraction. And then lastly, we go from equal sign to congruent symbol. So their measures are equal. Now we're saying the angles are congruent. And so that's definition of congruent angles. Okay, anyone have any questions so far about anything I've done? No. Okay. We have 2 more examples and we have about 10 more minutes in our time. So I'm going to do example 4 first because example 4 has the statements written in, and the practice that you're doing today, the statements are written in. I did want to do one blank one with you because eventually you have to do blank ones. We're kind of taking it slower this year. Like normally if we were in school right now, probably next class, we would have you do blank ones. But because we're in distance learning and I know proofs are hard, we're going to stick with just you doing the reasons. I think in the next assignment, we do have a couple where you're going to write out both sides or try it, but you're not going to be assessed on writing out both sides just yet. But we might still have you try it. So if we have time today, I'll do this blank one. But otherwise, I'll have you guys, I'll do it next time if we don't do it today. So let's do this next one. So this one involves, see this upside down capital T, that means perpendicular. So we're doing example 4 now. So that means perpendicular, which means you have right angles. So if you look at this picture here, it says AB is perpendicular to BC. So that would mean that this is a right angle, ABC. And then we're also told that 2 is congruent to 3. So we can mark those in the picture. Okay, so 1 is given. We restated all of that given information. Oh, speaking of that, I just want to say I should have changed my examples, but in the practice for today, There are some where they split up the given information. Like you don't have to put all of your given information in step 1. I usually do. I don't really understand why they sometimes split it up, but like I could put this here and I could put 2 is congruent to 3 like halfway down. Like a lot of times they'll do that. They'll put it in like right before they're going to use it. So just be careful on the practice for today. There may be some, like if you're stuck and you're like, where did this come from? I don't even know. Check the given and make sure that like it's not given or that it is given. You know what I'm trying to say here. So you might want to like look at if there's multiple pieces of given information, fill out all of those first. That's what I'm trying to say. All right, so step 2 says angle ABC is a right angle. So remember too that like this bottom stuff isn't really supposed to be here. So based on what we've been told that AB is perpendicular to BC and 2 is congruent to 3. We're concluding that ABC is a right angle. So you have to ask yourself like, how do I know that ABC is a right angle? Well, I was able to mark it based on the fact that these lines are perpendicular. So because the lines are perpendicular, that's how I know that ABC is a right angle. So you would just write definition of perpendicular. Because the definition of perpendicular is lines that form right angles. So if you know they're perpendicular, you can say that you have a right angle. Okay. Next is they're saying that the measure of angle ABC is equal to 90. So how do I know that ABC is equal to 90? Well, isn't that the definition of a right angle, right? If I told you that's a right angle, wouldn't you then know that it's equal to 90? So that's what this one is, definition of right angle. Okay, next says the measure of angle ABC is equal to the measure of angle 1 plus measure of angle 2. So 1 plus 2 equals ABC. Do we see how that small plus small equals big? So that's just angle addition postulate. Okay. Next is 1 plus 2 equals 90. Okay, so let's think about this. Do we see how 1 plus 2 is right here? So 1 plus 2 is equal to ABC, and ABC is also equal to 90. So this was some substitution. They took 1 plus 2 in this step and plugged it in here for ABC. You guys see that? So we took this, slid it up here, and that's where we're getting this from. So that's substitution. Okay, let's see what we have next. Next, we have the measure of angle 2 is equal to the measure of angle 3. So that is stemming from this piece of given information. So that's what I was saying before. Like in some proofs, they would put this right above where we would use it. But I usually just stick it all in the beginning. So this is coming from this. So because these are congruent, their measures are equal. And so the reason why we even have to do this, I think I said this last time, was if you're planning on substituting anything ever, it has to be in the measure form. So that's why we're randomly like switching it to this, because we're going to substitute it next. So this is definition of congruent angles. Okay, next is 1 plus 3 equals 90. So notice that that's very similar to step 5, 1 plus 2 equals 90. We just established that these were equal. So now I can replace the measure of angle 2 with the measure of angle 3. And that's where I'm getting step 7 from. So I took angle 3, I plugged it in for angle 2, and now I'm getting 1 plus 3 equals 90. So that's substitution. Which I didn't even talk about what we were trying to prove here. That would have helped. So we were trying to prove that 1 and 3 are complementary. So that's why we're saying that 1 and 3 add to 90, because in the end, we want to say that 1 and 3 are complementary. So you have to try to get it to say 1 plus 3 equals 90, which we did. And so now we're done. 1 and 3 are complementary. So you usually, complementary isn't always used in this like kind of backwards way, but if you know that they add to 90 and now we're saying they're complementary, it's just definition of complementary. Like, how do I know they're complementary? Because the definition is that they add to 90, and in this step, we're saying they add to 90. So this would be definition of complementary. And so that's that one. I'll leave that for a sec. Let me just make sure that I got everyone here. I think everyone's here except for Jean. She told me she wasn't going to be here. So let's see, there's 25 of you. Yeah, okay, you're all here. I'm not going to do an attendance form just to save time today. So we still do have a few minutes that I could keep you, but I'm going to start example 3, just so you see a linear pair one. If you feel like you are just ready to start the practice, you can go ahead. There's 6 proofs that you're going to do. But I realized that none of the examples I did talked about linear pair, and that's kind of one that kids find tricky. So I'm going to start example 3 right now and do the blank example 3. So you can feel free to stay if you want to watch the last example. Okay, so here's how we would do a blank one. So we're given that 4 and 5 form a linear pair, 6 and 7 form a linear pair, and 4 is congruent to 6. I already restated all the given information. Typically, anytime you're given that there's a linear pair, we want to say that they're supplementary. And so the reason why we do that is we can eventually say they're equal to 180, and we can do substitution, and you'll see. So us being told that it's a linear pair, that they're linear pairs, I can now say that they're supplementary by the linear pair theorem. So I would say angle 4 and angle 5 are supplementary. Oops, I ran out of room. Okay, you get the idea. And then angle 6 and angle 7 are supplementary. And that would be linear pair theorem. So anytime you're told they're a linear pair and then they say that they're supplementary, that's linear pair theorem. Okay. Think about what are supplementary angles? What do we know about supplementary angles? Supplementary angles add to 180, right? So that's what we can say next based on the definition of supplementary. So how you would write that is you have to write measure of angle 4 plus measure of angle 5 equals 180. And then measure of angle 6 plus measure of angle 7 equals 180. And that would be definition of supplementary. So our goal here, let's like recap what our goal is. Our goal in the end is to have 5 and 7, 5 on the left, 7 on the right. We're trying to say 5 is congruent to 7. So if I can have the measure of angle 5 on one side of the equal sign and the measure of angle 7 on the other side and somehow get rid of the other ones, then I've reached my goal. So that's kind of like my thought process here. So now that I have these two expressions both equal to 180, I can set them equal to each other and have 5 on the left and 7 on the right, and I'm like almost at my goal. So I'm going to have measure of angle 4. I didn't really give myself much room here, but measure of angle 4 plus measure of angle 5 equals measure of angle 6 plus measure of angle 7. And that would be substitution because they're both equal to that 180. Oops, I started talking and now I can't spell. Substitution property of equality. This is supposed to be a 7. Okay, so now what we need to do, we were told that 4 and 6 are congruent. If I could like replace 4 with 6 and then subtract them, then I would have 5 equal to 7, right? So in order to do that, I need to take 4 is congruent to 6 and I need to switch it to the measure form if I'm going to substitute it. So that's what my step 5 will be. Measure of angle 4 equals measure of angle 6. And that's definition of congruent angles. now that I switched, I wish I didn't write perpendicular right here because I really need that space. Now that I switched to the measure form, I'm going to substitute. So I could either replace 4 with 6 or 6 with 4. It doesn't really matter. I'm going to replace 4 with 6. So we're going to have measure of angle 6 plus measure of angle 5 equals measure of angle 6 plus measure of angle 7. And that's substitution. Sorry, this is going to get messy in a second. So now that I have 6 on both sides, I can subtract 6 from both sides, and then I'm left with measure of angle 5 equals measure of angle 7, and then I'm almost at my goal. So if I subtract 6, that leaves me with measure of angle 5 equals measure of angle 7, which is subtraction. I'm just going to cross this off for now because it's really bothering me. Okay, I gotta get the white out. So now for step 8, I'll squeeze it in here, is the final step. Angle 5 is congruent to angle 7, and that's definition of congruent angles. And so that's that. I'm gonna make this a little bit neater here with my white out. So I just wanted to show you a blank one. Like I said, you're not going to be assessed on blank ones quite yet. Eventually on like different types of proofs that we're going to do later in the year once we're in school. But for now, we're just going to have you do the statements. But next time, the reasons. Next time we will do a little bit of practice with some blank ones just so you guys can give it a try. Okay, so